Okay, in case you haven't found it yet, there's an exam, a final exam on e-courses in the top section where the common resources are. So let's talk about that. So the first problem asks about something that could go wrong if this code there is used. So it's explain in detail why it is dangerous to run a program with a code in listing 1. Obviously not only this code, but what could be dangerous, what could happen if we accidentally do this? Okay, so what could happen?
It's looking for the third value inside the char string line.
And?
And there is, and it's also assigning a value to it.
And? What's wrong about that? What's dangerous? Could you I mean, maybe not right away. I mean, right now it's still okay, but right now it's still on the right page. Okay, let's do one thing that often helps. Let's draw a memory diagram to clarify the situation, to envision what goes on here. So we have a pointer variable, myPDR. And it is at some address. It's irrelevant what address that is. It has some content, an address of course, but we don't know what address this is. So what we're doing now is we're taking that address, whatever it is, we're adding 2 to it, and then we're going to that memory location somewhere, and we're dropping a 0 into that memory location. The character 0. Whatever it is that we drop there, it doesn't really matter. We're dropping something there, and it's very likely not what was there, and it's quite possible that this address is outside of the range of memory locations that are allocated to our program. So what could happen? From the bird's eye perspective, you could say it is undefined to do this because we have an uninitialized pointer, and so therefore dereferencing that pointer or that pointer plus something is undefined. That's the bird's eye perspective. In more detail, what could happen is that just by chance there is an address in myPDR, and that address plus 2 is the address of some other variable in our program. And in that case, we would be overwriting the value in that memory location. What else is possible? It is possible, theoretically it would also be possible that it's the address of some instruction in our program that we are then overwriting with a 0. and thereby changing the instruction to something, whatever. That's possible. And as I said earlier, it's also possible that the address, whatever is found in my PDR plus 2, does not belong to the addresses allocated to our program. And in that case, we would get a runtime error, a segmentation violation. So the bird's eye view is it's undefined what happens, and then there's a few scenarios what might happen. It might be that we don't see it, right? It might be that if by chance the address stored in my PDR is the address of another variable in the program, and our program goes through an execution path where that variable is induced, then we might not even see that this has gone on. Yeah? Okay, so that's what could happen. Any question? Okay. The next one is asking you to explain what a dangling pointer is, how do they occur, how do they occur, I should say. What is the danger they present? And that's closely related to this, right? As I explained to you yesterday, loosely speaking, a dangling pointer is any pointer where the dereference is undefined, so this would be one. So one way of having a dangling pointer would be to have a pointer and not initializing it. And another way would be to delete it, yes, to assign something to it through the new operation, and then to release that memory location and still have the address in there. Yeah. And what danger do they present?
Well, isn't it what we just talked about?
It's very similar, very exactly that danger. Yes, exactly. Well, actually, there's a bit more. Here we're just using the pointer to access a variable to write into. But of course, when you have a dangling pointer and you read from it, it's also possible that it's possible that you can still read from it, but that the value has changed for whatever reason. Okay, so the next one, number 2. Compare and contrast C strings and strings. How are they alike and how are they different? You don't have to type all that because the exam is on eCourses.
Oh, I know. I'm typing down the answers.
Oh, okay.
yeah, so I can
Okay.
review them later.
Okay, so C strings and strings, how are they alike and how are they different? There's quite a lot of similarity and there's quite a lot of differences, so just start somewhere. I know it's early. Tell me one difference between C strings and strings. Or one similarity.
C strings versus strings. C strings can be initialized as an array character.
C strings can be initialized
As an array.
as an array? Okay, you mean like this. I can have a C string, for example, name. And I can initialize it as an array like this. Yeah. Whatever. And in that case, I have to watch out. If I want to do it like that, I have to watch out that I put the backslash 0 in there. Otherwise, it would not be a C string. Okay, yeah, that's true. I can do that, even though it's not very convenient. So that wouldn't be the first difference that comes to my mind.
There's also that C strings hold a /0.
It's a backward slash, yes, but yeah, in a C string, we have to watch out for this backslash 0 being present within the string. That really is part of a more high-level difference. With C strings, the programmer can directly go into the data structure and change bits of the data structure directly, and therefore is responsible for maintaining the backslash 0 occurs within the declared size of the array. For the string objects, you don't really directly go into the structure that stores the content. You can only do that through the functions that the string class provides, through the member functions. So you cannot directly access the internal representation. That's one fundamental difference. Okay. Obviously, there's a consequence of that. Namely, that there are certain mistakes that you can make with the use of C strings that you will not be able to make with the use of strings. Yeah? If the functions that operate on the strings are implemented correctly, then whatever intermediate result you will have after doing some string operations on a string object, it will always be a legal string object in the sense that it is structured properly. Whereas if you have a C string, on the other hand, you can pretty much make it an invalid C string by losing the backslash 0, by overriding the backslash 0. And so if there's no backslash 0 occurring in the declared size of the array, then it isn't a C string anymore. And that can happen because of operations that that the program performs, that you wrote on that C string. Okay, so that's a difference. That's a big difference. But there's another difference. I mean, you've worked with strings, have you? You've worked with C strings. Which one did you like working with better?
C strings.
C strings, really?
Well, it's because they're easier to manage, and you can modify every aspect of the C string.
Wow, I'm surprised, because the strings are normally, the strings offer much more convenience.
They're easier.
Easier, you think?
Well, yeah, because you just declare them and use them. You don't have to watch out for anything.
The strings?
Yeah.
Yeah, the strings are easier, not the C strings.
Oh, yeah, that's what I meant. Strings are
Oh,
easier
okay.
to use.
Yeah. I thought I heard you say the C strings are easier to use. No. Yeah, the strings are easier to use. Yeah. Absolutely. So the string class offers more convenience. It has lots of functions, again, done in a way that prevent you from making certain mistakes. For example, we talked about what can happen when you use the function strcpy or strcat, that you as a programmer are responsible for ensuring that the size of the target isn't overwritten, that it doesn't go beyond the size of the target, and that it is null terminated within that size. And those are all things that are being taken care of for you when you use the string objects. How are they alike? What can I store in a C string?
String variables, character variables.
I can store a sequence of characters, right? Yeah. So I can store a string, a sequence of characters in there, and I can do that in either one. Yeah. What about indexing? Can I use indexing with both the C strings and the string objects? No? You can. So that's another thing that they have in common. The indexing operation looks exactly the same. Whether I have a C string whatever, or whether I have a string object, this way. So whether I use a C string, what is 5 by 1? 0, 1, 2, 3, 4, 5. Yeah, that would be a string then. Whether I use a C string, I can use the indexing, or whether I use a string object, I can use the indexing, and it looks exactly the same. What goes on behind the scenes, so to speak, is different. Yeah, we for the C string, we really know what goes on in memory, and for the string object, it depends on the implementation. You would have to see the source code of the implementation. The indexing operation for the string objects, or for the string class, is overloaded, and so there's actually a function being executed whenever you use the indexing operation, and how that function operates depends on the implementation of the string class, and that in turn can be different from one vendor to another, or from one operating system to another, whatever. Even from one version of the library to another, it could be different. Okay. Any doubts or questions about this one? Dynamic arrays and static arrays. Compare and contrast. How are they alike?
I guess you could say the indexing also.
The indexing, yes, they both offer the indexing. That's definitely true. They can store a collection of values of the same type. In that case, in that sense, they're the same. What about differences? What was one of the key differences of the dynamic arrays versus the static arrays? One of the key differences.
The dynamic array can change in size.
Change in size, almost.
The way you define them.
It can change in size from one run of the program to the next. Yeah, but because you decide at runtime what the size will be.
Yeah.
So it can change from one run to the next, but once you declare it to a certain size, once you allocate a certain size, that size is fixed, and it won't change. Yeah, so that's a difference. Also, when you allocate it, or when you fix the size, I mean, in one case it's at compile time, in the other case it's at runtime. Any questions on that one? Okay, then on number 3a, does the program in listing 2 compile or not? If you think it compiles, what will it output? If you think it does not compile, explain why not and show how to fix it. So listing 2. So the first question is, will it compile? So is there a syntax error or something else missing? Well, one thing we could do is we could first check, are all the includes there? Are any includes missing? It actually has an include too many. It has an include that's not really needed. That's the C math, because there is no math function that we really need here. We do need C out, so IO stream is necessary. But that is it. So that extra include won't hurt us. It's not necessary, but it won't keep the program from compiling. So that part is okay. What about that const int size equal 10? Is that okay? Does that look good? Anything fishy about it?
Should it be inside?
No, it's a constant. It can be global constant. It's a constant that in this case is defined outside of main. There's no harm in that. Yeah, so then the next 4 lines, is there anything wrong there? The function header for main, the declaration of the variables, the assignment of the first 2 positions in the array A. Does that look good? Yeah, looks good. So then the loop header, the loop control for I equal to 2. Is that okay? Can I start at 2? Don't I have to start at 0 or 1?
You don't have to start at 0 all the way.
No, right. Of course. Silly question. Yeah, of course, you can start the counter at any value that you need. Remember, in the for header, any instruction really is allowed for the initialization, and any instruction is allowed for the update. So of course you can assign any value to a variable. Okay, yeah, that's good. Then inside the for loop body, A at position I is assigned A at position I minus 1 plus A at position I divided by 2. Does that look good?
Isn't it going to start at 0 though? Isn't it going to be 0?
What?
The I? Because it.
Well, the I is initialized to 2.
Okay.
Okay, so that looks good. And the next for loop header starting at 0. That looks good. And yeah, the rest is boilerplate, right? I mean, stuff that we've used a lot of times. Okay, so it looks good. It seems to compile. So then let's ask ourselves what it will output. What will it output? So we have to determine what's going to be the content of the A array. Yeah? The A array has 10 elements. So let's draw 10 elements of this array. starting at 0 up to 9. Those are our indices. And the first two positions are initialized to 2. Then what does the loop do? We're tracing I is initialized to 2. What do we do for I equal to 2 inside the loop body?
I have a question.
Yes.
So when you put 2 in the first two spaces of the array, are the other spaces put at zeros?
No,
afterwards? No.
not in this way. Not in this way that I'm using it. If I would have written up there in the initialization, if I would have written this, and then if I would have written this for the initialization, then the remaining elements would have been initialized to 0. But the way I am doing it, they are not. Okay, so what do we have to calculate for the loop body?
Next position 2.
Yeah, index position 2 is where it's going to go.
Index position 1
Yes?
plus index position
Plus index position
1.
Yes. So the value at index position 1 plus that value again. And then we increment I. And what do we do?
So I plus 3 here.
Hmm?
So it'll be index position 2 plus index position 1.
Yes, exactly. So a 6 here, and then we increment this 4, and then we add these two. No, wait, too quick. Index position 3 plus index position 2, yes. Was this right? Index position -1. Yes, this was right. So, we get 10, and we increment to 5. So then 5 minus 1 is 4, and 5 divided by 2 is 2. So we add these two together, we get 14. We increment I. And then here, that would be 5 and 3. So this is 21. And then for 7, we would use 6 and 3. 27. And then for 8, we would use 7 and 4. And then for 9, we would use 8 and 4. Yeah. How did I come up with 21 here? 5 and 3, that's 20. Right? Five and 3, that's 20, not 21. So So, in this example, it's just important to keep track of the proper indexing that's being used. In these kinds of problems, you have to watch out for whether the resulting array where the values are stored and the array where the values come from are the same. Yeah? If they're the same, then you really should watch out for doing these updates in place, because sometimes the array will be initialized to a state initially, and as your program proceeds, it changes some values in the array, and these changed values then go into further calculations that are used to determine the value of other array elements. Yeah? And if you just write down the initialization and you try to calculate a result from it, then you're likely going to use those initial values and not the updated values, and that's going to give you the wrong results. Yeah? So watch out for whether the array is updated in place, and then always use the updated values when you do further calculations. Okay, so the next one here talks about the program in listing 3, and I just want to copy the input that this program receives. Actually, I know it, so I don't need to leave that slide, leave that part up. So go to the, yeah, I think that's all good. So the input that the program receives is think about this ace the exam. Okay, so that's the input. Okay. So, is there anything unclear about the first line inside the main function? I would expect so. Okay, so that declaration says that we will have a char array of 300 elements called input. It's always a good idea to visualize how this is laid out in memory, what goes on in memory. So we have input here, and I'm gonna draw it. It's just a little space. It has 300 elements, 300 characters. And just for the sake of simplicity, let us say it is at address 1000. Okay. So what else do we have? We have star p. What is that? It's a pointer to a character, exactly. So let's place this one here. P. Do we know something about its value? Not at this point, exactly. So what's the next one? Q. Is it just one pointer?
The next value is a pointer to a pointer, which is pointing to a Q.
Yeah, but we're still talking about Q. One thing at a time. No, it is a static array of 300 character pointers. So it is an array where every element of the array is in turn a character pointer. So Q, let's say it's at address 2000 and it has 300 elements, and every one of those elements here is a character pointer. So every element of the Q array can hold the address of a character. Okay, and then the next one, Jan, you already said that correctly. It's a pointer to character pointers and it's initialized to Q. So R is a pointer somewhere, we don't care where, and it is initialized with Q. Q is this address, and it is the address of a character pointer, namely the first element in the the Q array. So we will have the address 2000 here in R, and it points to the first element in the Q array. Okay, well, the next thing that we do is we get the line of input. So imagine all these characters, one after another, are deposited in memory starting at address 1000. So the capital T with which it starts is at the address 1000, and then the lowercase h would be at the address 1001, and so forth. Okay, what do we do next? We have this loop header. For P is assigned input star P, P++. So when we first reach this for loop, we initialize P. So what should I put here?
Input. Or the value that's stored in input.
Well, which one? 1000. The address 1000 because input itself is the array name, and it just stands for this address as an address constant. It stands for this address where it starts in memory. So the situation we have now is that P points here, or if you want to look at it over here, P points here. Okay, so that's the initialization of P. Then this star P, what does that do? It's the dereference of P, right? So what happens is use the address that's stored in P, go to that address, and use the value at that address. The value at that address, or the variable at that address. The variable at that address contains the capital T. That capital T is used here in what context? Well, it's used here as the condition of the loop. So I have something that is not a Boolean, namely a character. That character is now automatically converted to a Boolean, and anything that is different from 0 is treated as true, and only the 0 is treated as false. So one thing to keep in mind, this star P, when P is a character pointer, that will be true until you reach the end of the string, because the end of the string is the \0. That \0 is a character with all bits set to 0, and it has the value 0. And when that appears where a condition is required, then it is false. And if we use that as a loop control, then of course we stop the loop when we reach the \0. Okay, so one thing that we can already say, I mean, every time around the loop, P is incremented. So what we have here is we have P will scan over the entire input until we reach the \0 that was put there by the get line. Yeah, when the user entered the new line, get line turned that into the \0 and placed it at the end of the string. Okay. Inside the loop, we have a switch case and only a switch case. Remember, the for loop really takes only a single statement for its loop body unless I enclose several statements in curly braces. That switch case is one statement. It's one statement, the entire switch case. So only that is part of the loop body. Okay. And we switch on the to lower of star P. What's that gonna do?
Uppercase letters into lowercase letters.
Right. The dereference of P, so we go to the variable where P points to, that's a character variable. We take the value there, it's the capital T in this case currently, and we convert it to lowercase. And then we switch on it, and there are cases for the lowercase e, the period, \single quote, that is the single quote, the character consisting of the single quote or apostrophe, and a space. So we have those three cases, those four cases. The lowercase t is none of these. So for the lowercase t, we just increment the pointer. We just go to the update action of the for loop and we increment the pointer. So P now points to the lowercase h. And so it will have the value 1001. Oh, well, that wasn't really very exciting, right? And since we only have cases for the lowercase e, for the period, for the apostrophe, and for the space, we can already see that for the h, the I, the n, the k, exactly the same is going to happen because for those characters we don't have a case. A case label that matches it. So we will eventually have P pointing here at the space, and P is going to have the value 1005. So what happens then? It matches one of the cases, right? So it matches this, the second case actually. I mean, because there are only there are 4 case labels, but only 2 case blocks. So what happens in the second case block? We do the reference P is assigned the \0. So what will that do to our picture here? Exactly. Very good. Exactly. The reference P, go to that variable and put a \0 into it. Right. And that's it. That's all we have to do in this case. And so we advance P . Yeah, and then we have the A, the B, the O, the U, the T. We already know that for those characters we don't have a case label. So we just keep advancing over those. Eventually we have P pointing to the space again, and as Jan correctly said, what happens in this case is that we override it with the backslash 0. And then the T, the I, the H, the S, they don't trigger anything special. And then we have P at this point, and again we override this with the backslash 0. And then again, all those characters, they don't have any special case except for the period. So when we reach the period, we're going to have to check again. So what happens for the period? And as you can see, the period is a case label, is another case label for the same code block that overwrote whatever position we were at with the backslash 0. So you're not going to be surprised if I tell you that this is going to be overwritten with the backslash 0. And then we advance to the space, and that space is going to be overwritten with the backslash 0 also. And then it goes on. The T, the A, the K, nothing special. And eventually we're on the E. And now it becomes interesting. So when P is on the E, what do we do? When P points to the E, what happens?
Store that value inside the pointer Q. In the position.
Exactly. So the reference R++ becomes P. What Jan said is right. I'm gonna explain it maybe in a bit more detail. The dereference of R, take the address in R, go to that address, use the variable at that address, use it for what? Use it for storing the current value of P in it. So I lost count. So here I know we were at 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 32 if I didn't miscount. So the value of P is now 1032, and that address will be recorded through a dereference of R into the first element of the Q array. And then we increment R so that it points to the next element. If we assume 32-bit addresses, then our address here would actually increase by 4 to point to the next element. If we have 64-bit addresses, then it would increase by 8, corresponding. It increases by the size of one address. Yeah. Okay, so very good, Janet. After doing that, we advance that pointer P again. And of course, as we already know, this is overwritten with the backslash 0. And then the Y, the O, the U, the R, they don't trigger anything special. The next space triggers an overwrite with backslash 0. Then the T, the I, the M, they don't trigger anything special. E, the E again, well, we already know what happens, right? The value of P is stored by dereferencing R into the next position in the Q array. So what is the value here? Here we had 32. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 42. 42. Oh, no, that was space. this one here is 42. And that 1042 goes here. And we advance the pointer R, point to the next variable. So, okay. Well, a space, we already know what happens. It's replaced by a \0. The A, the N, and the D, they don't trigger anything special there. The next space is again overwritten with a \0. The A, the C, nothing. The E, again we record the position. So if here we were at 42, 3, 4, 5, 6, 7, 8, 9, 50. So we should now be at 1050. And that address 1050 is recorded in the Q array, and we advance the pointer R into the Q array by adding okay, that space here is overwritten with \0, and of course and then we advance further to the E of the, and if that was 50, then this is 1, 2, 3, 4, 54. So we would now be here at 54, and we would record the address 1054 in the Q array, and update this pointer here. Okay. Then this gets replaced with \0. Then we have the E here. So this is 54, and this should be 56. And we record the 1056, and we advance the pointer into the Q array, and this is now here. And then for the X, the A, the M, we don't do anything special, and the period gets overwritten with a \0, and then we advance P once more, and now P points to the \0, and that is when the dereference of P as the condition of the for loop gives us a false, and we continue after that loop. So what we have now is we have in the Q array all the positions of the E's in here, and we've also modified the input array in such a way that every space and every period they were all overwritten with a \0. So now immediately after that loop, there's a dereference of R is assigned 0. So what happens here is that we put a 0 address here. Yeah? You will see in a moment what we do this for. Actually, you will see it again very, very quickly. So for the next loop, we initialize R to Q. That's how it was when we declared R, right? R was declared and assigned or initialized with Q at the start of the main function. So R now points up here again, And the condition is the dereference of R. So the dereference of R, take the address in R, go to that address, use the variable there as the condition. Well, use the value that's stored there. If that value is 0, it represents false. If that value is non-zero, it represents true. So it's going to be true, 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 false. Yeah. And R++, of course, is going to, every time around the loop, it's going to increment the address in R to point to the next address in the Q array, to the next element in the Q array. Okay, and then we do a cout, insert the dereference of R. The dereference of R is of what type?
Char.
Not quite.
Would be
The
an
dereference of R is not a char. What is it? What type does it have? What type did this have? Or look at the declaration of R. At the start, when we started discussing this, Jan, you said it correctly that R is a
point
2?
Q, which is initialized to 300.
It's a pointer to Q, yes, but Q holds Q itself holds in its elements what?
300.
What?
Numbers?
Yeah, but what numbers are those? What kind of numbers are those?
Index positions.
Addresses. Addresses of characters. Look at the declaration of R. It's a char pointer. So it is a pointer, yes, but to char pointers. Yeah. So R is a pointer to char pointers. That means when I dereference R, I have a char pointer. When I supply a char pointer to the insertion operation, the string that starts at that character position, that starts at that address, is output. The entire string up until the \0. That's how the insertion operator works. So what we will see in the output is the following. I mean, R is initialized to Q, yes. Star R, there's an address there that's not 0. So we take this address and we do a cout with this address and then a space. So what will this address give us? It was the address of this first E here. The string, the C string that starts at this address consists of only the E because there's a \0 right after it. So what that will output is an E and a space. And then we advance R to the next position. That was the E here. The same thing is true again. The C string that starts at that memory location consists of the E and nothing more. So another E followed by a space is put into the output. And then this position here was this E here. Same thing is true again. We see another E and a space. And then the next position in the Q array is this E, is the position of this E. So there's another E in a space. And then the last entry that's non-zero in the Q array is the E here. So we see exam printed, followed by a space. And then we have R pointing to this here, so the dereference of R is 0. And that's when the loop ends. So this is going to be the output. Any questions?
That's gonna be the final output.
Yes? That's gonna be the final one. Yes. And I would really like to do something with you, but since the projector isn't working, I won't be able to do that. I was going to show you how you can use the debugger to go through this and to investigate what goes on in memory. There's only really a few commands that you need, but you need to see the commands together, and I don't think I can just write them on the whiteboard. I don't think that would work. I really would have to demonstrate. But without the projector, we won't be able to do it. Okay. Any questions or doubts here? There's a lot of YouTube videos on using the debugger. I'm pretty sure that if you spend a little time, you will find the right ones that show you how to investigate memory. Essentially, there is a command P for print, N for next, going to the next instruction, and with P you can use expressions of your program. So, for example, you could say P Q 0, and it would print out the address that is stored in position 0 in the Q array. But as I said, that's really it's the whiteboard is not a replacement for the demo here. But it's not very many different operations that you need to use in order to explore memory of a program like this one. So, we're through with this exam.
The exam is gonna be on Monday, 9:45, if I'm not mistaken, right?
I haven't checked it. 9:45?
Yeah, I think it was.
And Monday, that's the
26. 27. 26, something like that. Let me check. Let me be 100% sure.
okay. But it's gonna be Monday.
Yeah. 26th of June, 9:45 at Stephanie 204.
Yesterday you said that you were gonna prepare some questions for today. No questions?
All my actual doubts were just answered with this
Yeah.
little review, yeah.
Yeah, I mean that program packs a lot of the pointer stuff and array stuff into it. So, yeah.
The final tests include vectors, as in we have to use them or know how to use them at least.
Well, I mean, as I said, it will focus on the last 3 chapters, and the vectors were in the last 3 chapters. So, I'm not going to exclude them. When it comes to using tools that we talked about, like programming language features, of course you're gonna have to use anything and everything. There might be function calls even though they weren't in the last 3 chapters. There might be call by reference parameters, even though they weren't in the last 3 chapters. It's only with respect to the topics that I choose for the compare and contrast questions that I'm going to limit myself to those more recent topics. For code comprehension or for code completion, it wouldn't really make sense. I mean, can't write a program, or can't really write a sensible program without a variable, right? Well, if you write this so if you write this, what do you expect to see in the output? Yes. Exactly. So if I write this, I expect 50 in the output. If you write this, what do you expect in the output? What?
An error of some sort?
No, it's not an error. It is going to output the address where the variable is in memory. And so very likely the output would be something like OX BFFE 7 BCD or something like that. Yeah? But here's something that we just used on that program. If you have, on the other hand, a char pointer and you have initialized it, let's say like this, and then you've done a string copy and you filled it with something. And then you do a cout star p. What will you get? What will this here output? Oh yeah, there is. We've initialized it to point to the first element of that array. So we have P, and then we do a new char 300. So that doesn't have a name, but it has an address, let's say at address 3000. And that address is stored in P. So P points to the first element of that array, and then I do an strcpy. So the characters H, E, L L O backslash 0 are in this array. And now if I do dereference P, I'm selecting this variable. So I get the capital H in the output. Yeah. It's the I'm dereferencing a character pointer, so I'm getting a character variable. When I use that character variable to insert it into the output, the value is printed. Okay, what if I do this? And now the behavior is different to here. The behavior of the insertion operation, when it sees an integer pointer, it gives me the address in memory where that integer pointer is. The behavior of the insertion operator when it sees a character pointer is not to print the address, but instead to start printing the characters starting at that address until it runs into a backslash 0. So it treats it as a C string. It treats the insertion operator treats a character pointer expecting to find a C string starting at that position. So there's a difference here in the treatment of the pointers, whether it is an integer pointer or a character pointer. Any other questions? Doubts? Well, I mean, I don't have anything new to do, so.
So, what was the difference then in the program from the practice exam where we pointed? So the R was a pointer to a character pointer, right?
Exactly.
And then
So when you dereference it,
yeah,
you have a character pointer.
exactly. But when we called, we dereferenced it to a character pointer and pointed to a character, but then it would output everything into the space. Why not just the
Just the character?
yeah?
Yeah, because it was a character pointer, and when that's what I just illustrated here. When P is a character pointer, in our example that we did on that problem, the dereference of R is a character pointer. Yeah? Not a single character, a character pointer. If I would dereference it again, if I would do a star R, dereference the dereference of R, then I would have a single character. Okay, well, any other questions, doubts? I suggest you come up with some questions for tomorrow then.
What will we do tomorrow?
Answer your questions. Yeah, I mean, without the projector. Maybe I find time to do what I was going to project on my computer and to record it and to upload it. But I mean, I definitely won't find time to edit it, so it would be just a raw recording. Okay, well then we're gonna leave it at that for today.